Good evening, ma'am.
Good
Good
evening,
evening, ma'am.
class.
Good evening, ma'am.
Good evening.
Good evening,
Good
ma'am.
evening, ma'am.
Good evening, ma'am.
Good evening,
Good
ma'am.
evening, ma'am.
So we'll be starting with the second unit. Second unit is about differential calculus. Differ- um, Differential calculus in one variable, and we will be discussing about single and higher order derivatives. So though I understand that you are aware of differentiation, derivative of a function, but still we are going to take it as it is mentioned as per the syllabus. So we will be starting with it. So I hope you all are aware of what a derivative of a function is, but still you would have to write the definition, basic things, basic definitions that I would suggest you to write, as most of you would not be having book or anything. So it is better that you write the uh, definitions. So please write down, let y equal to fx, y equal to fx be a real valued function, be a real valued function, be a, I hope I am audible.
Yes,
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 ma'am.
ma'am.
Yes,
ma'am.
yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So let y equal to fx be a real valued function defined on an interval I, defined on an interval I, capital I. One second, I should have started the screen share also. Just a minute.
एक्सक्यूज मी मैम।
हाँ जी।
मैम, पहले आवाज नहीं आ रही थी, आपने अटेंडेंस ली है क्या अभी?
नहीं, मैंने तो कोई अटेंडेंस नहीं ली।
अच्छा मैम, मेरे को लगा क्योंकि आवाज नहीं आ रही थी ना मेरे को, तो मेरे को लगा आप अटेंडेंस ले रहे हो।
नहीं, इफ आई एम म्यूट देन आई एम, आप वो देख सकते हो ना म्यूट है या अनम्यूट है।
मैम वो अनम्यूट था, मगर मेरा पता नहीं सिस्टम काम नहीं कर रहा था।
चलिए ठीक है। So let y equal to fx be a real valued function defined on an interval I. It is a capital I, and let x naught be a point, and let x naught be a point in I, and let x naught be a point in I, then fx is said to be differentiable. then fx is said to be differentiable at x equal to x naught if limit x tending to x naught fx minus fx naught upon में x minus x naught exist, or is sorry, the limit, this limit exists, this exists and is finite. And similar thing can also be written as, this thing can also be written as, we can write it as x is equal to, as we are saying that x is approaching x naught, so we can say that x is equal to x naught plus delta x, right? We can say like this also. So basically x minus x naught is equal to delta x. So I can also write limit delta x tending to 0 f of x plus delta x, x naught plus delta x minus f of x naught upon में delta x, right? So these two limits are same. So these two limits are same.
Yes.
Any doubt in this?
No, ma'am.
No, ma'am.
So I'm saying that a function
No,
y
ma'am.
equal to fx is differentiable on an interval I at a point x naught. Then this is differentiable if limit of x tending to x naught fx minus fx naught upon my x minus x naught, or limit of delta x tending to 0 f of x plus delta x minus fx naught divided by delta x exists and is finite. Fine. So this is the simple definition of the differentiation. The derivative of a function fx at x equal to x naught is denoted by, how do you denote? So you can write down that derivative of a function. If I have a function this, if I have this function, then this can also be written as, let us be on the same page so that we know how we are denoting certain things. Is equal to dy by dx, or if I say that I'm differentiating this function with respect to x. So this is the common notation that we use. And one more notation that we can use is capital D f of x. ठीक है? So if I say that I'm just I'm just making a statement that if I say that if fx is said to be fx is said to be differentiable in the interval a, in the interval ab, if I say that a function is differentiable in the interval ab, then it is differentiable in the interval ab if and only if fx is differentiable at every point in of the interval ab. ठीक है? It should the derivative should be defined at every point in this interval. If the closed interval, if I am using this closed interval, this is an open interval. I hope you all understand that this is an open interval. Here the
Yes,
values
ma'am.
of a and b are not included in the interval. When I want to denote a closed interval, I will denote like this, where the values of a and b are also included. So if the closed interval AB is then we say that fx is differentiable at every point of this closed interval AB. If fx is differentiable, so this includes the fx should be differentiable in this interval at A and at B, right? This is what we mean by this closed interval AB. Okay? So what this is saying is that the function should be differentiable. This includes this entire thing. Okay?
Ma'am, could you please repeat it once? I actually
Yes,
lost my
ma'am.
connection.
That's okay. Uh, what I was saying was कि अभी हमने बात करी थी, अगर हम ये कह रहे हैं कि अगर हमें ये कहना है that a function fx is differentiable in the interval in an open interval ab, then it should be that the derivative of that function should exist at every point between a and b. So if I say the points are 2 and 3, so the derivative of a function f should exist at 2.1, at 2.2, at 2.3, at 2.4, at every point between 2 and 3. Now, if I consider the closed interval a comma b, then it says that if I'm saying that a function f is differentiable in the closed interval ab, then the function should be differentiable in the open interval ab. The function should be differentiable at a, and the function should be differentiable at b. Fine?
Yes, ma'am.
Yes, ma'am.
Okay. Is Saurabh here? Saurabh here. Is the CR of the class Saurabh here?
मैम उसने ज्वाइन तो करा था पर उसके नेटवर्क इश्यूज हैं तो उसकी हर क्लास लीव होते जा रही है.
Saurabh is not here. क्या कह रहे हैं आप?
मैम उसके नेटवर्क इश्यूज आ रहे थे आज तो वो बार बार उसकी हर क्लास में लीव हो रही थी.
Okay. Can anyone inform on the class group that I will not allow Yapin Ahuja for the class as he is late? It is not acceptable, beta.
Okay.
Okay, ma'am.
I will not allow after 15 minutes. He was trying to enter the class at 5:17. Okay. So if we try to understand, um, is the screen visible? So if we try to understand geometrically what is the meaning of a derivative of a function fx at a given point x naught y naught, then we mean that it gives the slope of the tangent line to the curve y equal to fx. ठीक है, तो जो लाइन इसके टेंजेंट होगी, जो लाइन ये एक सेकंड, तो जो हमारा कर्व है अगर हम इसको डिफरेंशिएट करते हैं then that difference derivative is basically the slope of the tangent line to the curve at the point P. ठीक है, इस geometrical notation में any doubt?
No, ma'am.
Any doubt?
No,
Are
ma'am.
you able to visualize what a derivative of a function means?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Because
Yes, ma'am.
आगे बहुत मुश्किल हो सकती है, थोड़ा सा और कॉम्प्लेक्स हो सकता है. अगर मैं किसी कर्व की बात कर रही हूँ, किसी कर्व पे अगर कोई पॉइंट है P, तो मुझे जो अगर मैं इस पॉइंट पे इस फंक्शन का, अगर ये फंक्शन है, सॉरी ये फंक्शन कोई फंक्शन है f, and I want to find the derivative of this function at point P, तो बेसिकली क्या होगा वो, तो इस this value is basically the slope of the line of this curve at point P. ठीक है. So also if a function y is equal to fx is differentiable at a point P, it is necessarily continuous there. But ऐसा जरूरी नहीं है कि inverse भी converse इसका true होगा. That is, if a function is continuous, then it may happen that it is not differentiable. But अगर कोई function आपका differentiable है, तो definitely वो continuous भी होगा. I think this is also fact you are aware of, right?
Yes, ma'am.
Yes, ma'am.
Okay, so if we have two functions f and g, and if we have two functions f and g and they are differentiable functions, then the following properties are satisfied. it is just a revision of the properties of differentiation. You would have used and applied these definitions in your 11th-12th standard. So if I want to multiply a constant with a derivative, it is basically the same as this, right? This is same. So if I want to add two functions and to a derivative, it is same as that I first take the derivative and then I add or subtract them. For multiplication, if I multiply two functions and then take the derivative, it is same as taking the derivative of first, multiplying with second, plus multiplying the first with the derivative of second. And similarly, taking the division of a derivative of two functions and then taking the derivative means gx into derivative of first minus g dash x into into first divided by square of second function. So now if I want to define a new function, that is g of fx, then h dash x is basically this h dash x. I hope this also you are mostly aware of, that you apply the chain rule.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
इसमें हम बेसिकली क्या करते हैं कि अगर हमारे पास so if I have h is equal to g of fx then if I want to take the derivative, so it is equal to g dash of fx into f dash of x, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So now do one question, write down one question, this check whether the function fx equal to ln x mod of ln x is differentiable at the point x equal to 1. Check, please write down this question. Check whether the function fx equal to mod of ln x is differentiable at the point x equal to 1.
No, ma'am.
So what is the value that you are getting?
मैम वो मैंने ग्राफ बना के फिर उससे किया है.
बट एग्जाम में अगर आप ग्राफ बना के करोगे तो उससे तो नहीं होगा. यू वुड हैव टू सॉल्व द एंटायर क्वेश्चन. हाउ विल यू डू इट देन? हाउ विल यू शो दैट?
राइट हैंड डेरिवेटिव और लेफ्ट हैंड डेरिवेटिव निकालेंगे इसका.
राइट, आप इसका राइट हैंड डेरिवेटिव एंड लेफ्ट हैंड डेरिवेटिव निकालेंगे एंड दे आर नॉट गोइंग टू बी और दे आर गोइंग टू बी सेम.
अलग अलग
Not
आएंगे. एक
going to be
अलग
same.
अलग
वन होगा,
होंगे.
एक -1 होगा.
हाँ, दे आर गोइंग टू बी डिफरेंट. तो क्या वैल्यू आ रही है इनकी, राइट हैंड डेरिवेटिव की और लेफ्ट हैंड डेरिवेटिव की?
राइट हैंड +1 आएगा और लेफ्ट -1.
Minus 1.
राइट, सो दे आर नॉट गोइंग टू बी. So it is not differentiable at x equal to 1, right?
Yes, ma'am.
How do you define the higher order derivatives? You can write down the derivative of a function fx. Please write down the derivative of a function fx. The derivative of a function fx at any point x, at any point x, if it exists, the derivative of function fx at any point x, if it exists, is a function of x, and and f dash x and f dash x is equal to gx. This is how you write the derivative of function fx at any point x, if it exists, is a function of x. You can write it as f dash x is equal to g of x. एक second. Thus, in case if ever I am not able to share my screen, so just to define some common terms, that the common notation that we are going to use is fx अगर मैं बोल रही हूँ तो it means that there is a function of x. ठीक है, अगर कभी मैं एक्सप्रेस
Yes, ma'am.
ठीक है, अगर मैं कभी एक्सप्रेस नहीं कर पा रही हूँ या कहीं नहीं लिख पा रही हूँ, तो if I am writing fx, then it is a function of x. It is written like this. If I am saying f dash x or first order derivative of x, then it is f dash x. Right? If I am saying second order or higher order derivative, it is f double dash of x. Or if I am saying f double dash of x. So if ever I'm not able to express where I'm just asking you to write something, then you can simply write it like this. If I say fx, f dash x or f double dash x. ठीक है, या फिर इसकी जगह gx हो सकता है, hx हो सकता है, h dash x हो सकता है, या h double dash of x हो सकता है. So you can have any way, right? If I ask you to write n minus 1th derivative of f, if I ask you to write n minus 1th derivative of x, so it is going to be something like fine. So this function g is basically the n minus 1th derivative of function f with respect to x. Fine. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. So the derivative, the second derivative of fx is defined as f double dash of x. Second derivative of fx is defined as f double dash of x, which is equal to g dash of x. अभी हमने ऊपर क्या डिफाइन किया था कि अगर हमारे पास कोई फंक्शन fx है और उसका डेरिवेटिव अगर एग्जिस्ट करता है, then it is written as gx is equal to f dash of x. अगर अब हमें now if we want to define the second derivative of fx, then it is written as g dash of x is equal to f double dash of x. ठीक है? Is it clear? Anyone has any doubt? Anyone has any doubt? Okay. So nth order derivative of fx, nth order derivative of fx is defined as f raised to power n x. मतलब जो अभी नोटेशन मैंने यहाँ लिखी थी, it is same as this कि the nth order derivative of fx is written as f of n is equal to basically d of dx of f of n minus 1 of x, right? Now next is a very important rule. You can write down Leibniz rule. It is not the Leibniz test, it is a Leibniz rule. I hope you know the spelling of Leibniz. L-E-I Leibniz rule. So the Leibniz rule is about the, you can write down, Leibniz rule is about the nth derivative of product of two functions. right? Leibniz rule is about nth derivative of product of two functions. So how you are going to write it as? It is basically, if you have two functions f and g, you take the product of the functions and then you define the nth order derivative of this. Then how will you express this? How will you define this? So the Leibniz rule is about this definition. So this definition says that I'm writing it here. It is nth derivative of f into g plus nc1 into f raised to power n minus 1th derivative of f into first derivative of g plus nc2 n minus 1th derivative of f, sorry, n minus 2th derivative of f into second derivative of g plus nc3 n minus 3th derivative of f g triple dash plus up to ncn, yeah, let's take ncn minus 1 f dash g n minus 1th derivative of g plus ncn, which is 1 basically, f into nth derivative of, I'm writing this in brackets just to make sure this is the derivative and you don't get confused with power. Is that clear?
Ma'am, your voice
Yes,
got
ma'am.
cut. I didn't hear anything.
Yes, ma'am.
Sorry?
After you said I'm writing it in brackets, I didn't hear anything. It got cut. Can you
Okay.
repeat that, please?
So I said that I'm writing. Otherwise, it was audible before that.
Yes, ma'am. It was audible before that.
Okay. So I said that I'm writing this power n, n minus 1, n minus 2, n minus 3, this n minus 1, and I'm writing this in brackets just to make sure that these are the derivatives and not the powers.
Okay, ma'am. Thank you.
Okay? Yes. Okay. So just a minute. Hanji. So this Leibniz rule is clear?
Yes, ma'am.
Okay. So now write one question. Find the nth order derivative of the function. Find the nth order derivative of the function. Find the nth order derivative of the function y is equal to 3x plus 2 divided by x square minus 2x x square minus 2x plus 5 at the point x equal to 0. At the point x equal to 0. You can use the Leibniz rule in finding the derivative. How will you do it? How will you do it? Class, how will you do it? By applying the Leibniz rule. Any idea?
No, ma'am, no
ma'am.
idea.
We
So how can you write it?
first divide the y term into functions.
What we can do is, आपके पास जो function है y is equal to 3x plus 2 divided by x square minus 2x plus 5. This can be written as y into x square minus 2x plus 5 is equal to 3x plus 2. ठीक है? You can write it like this.
Yes, ma'am.
Fine. अब मुझे इसका nth, now we define the nth derivative on both the sides. मुझे find out क्या करना है? yn find out करना है. I have to find out yn. So if I define the nth derivative of this function, what it is equal to? Y की power n, मतलब nth derivative of y into x square minus 2x plus 5. आगे क्या आएगा इसके? NC1 क्या होता है?
n
n into n minus 1th derivative of y into first derivative of this function. What it is equal to?
2x minus 2.
2x minus 2 plus NC2 क्या होगा? n into n minus 1 n into n minus 1 divided by 2 y n minus 2 क्या होगा इसका डेरिवेटिव? 2 right is equal to what it is equal to?
0
n into n minus.
है ना? इसका तो फर्स्ट डेरिवेटिव ही निकाल सकते हो सिर्फ, बाकी तो जीरो हो जाएंगे इसके डेरिवेटिव्स.
Yes, ma'am.
एक सेकेंड, बिफोर दैट इफ आई से प्लस NC3 y की n माइनस 3 डेरिवेटिव इंटू 2 का डेरिवेटिव क्या होगा?
0
0. तो यहाँ से तो सारी टर्म्स आपकी जीरो हो जाएंगी.
यस मैम.
इसके बाद तो आप इवेल्युएट कर ही नहीं सकते. एंड इट इज इक्वल टू 0, राइट? So you have only this term. You have only this term to solve. Now you can solve this.
Yes, ma'am.
करिए solve. Put it in a quadratic equation. Also, what you have to do is, क्वेश्चन में दूसरा पार्ट क्या दिया हुआ है? You have to find the nth order derivative of this function at the point x equal to 0. So when you are asked to find the x derivative at x equal to 0, you can also substitute the values at x equal to 0. अब आप इसके अंदर इसके अंदर आप x इक्वल टू 0 पुट करोगे तो क्या बन जाएगा? क्या बन जाएगा बच्चे?
मैम 2/5 into 5.
2/5 क्यों?
मैम y
5
मैम y
into
is
5 की
5 y to the power n minus 2n y की power n minus 1.
2n into y की पावर या n minus 1th डेरिवेटिव ऑफ y at 0
Plus
प्लस
n minus 1 y derivative n minus 2.
ये तो 2 से 2 कट जाएगा.
Yes,
n
ma'am.
into minus 1 y की पावर n minus 2 बचेगा.
It is very difficult to write on like this. So this is what you have. Please solve it fast. Solve this equation. What do you get? क्या आंसर आया बच्चे? बेटा क्या आंसर आया इसका? What is y dash? Sorry, nth order derivative of y at 0?
ma'am it should be 0 if we take y raised to the power n common from this equation. We can say that y raised to the power n of 0
आप
is
वो
equation
power n
वो
नहीं है, वो
पावर नहीं है,
डेरिवेटिव है वो.
वो डेरिवेटिव
उसको
है
कैसे
वो.
कॉमन ले लेंगे?
derivative है.
sorry, derivative.
उसको पावर नहीं ले सकते, राइट? उसको पावर नहीं ले सकते हैं. तो बेसिकली आपने इस इक्वेशन को सॉल्व किया. व्हाट यू शुड गेट इज nth order derivative of y at 0 is equal to 2/5 n into y n minus 1th derivative of y at 0 minus n into n minus 1 divided by 5 n minus 2th derivative of y at 0. So it is a recursive equation in the form of n minus 1th derivative of y and n minus 2th derivative of y. Is it clear? Or should I
Yes,
write it?
Yes,
Or
ma'am.
should I write it for you? तो बेसिकली अगर आप इस इक्वेशन को सॉल्व करेंगे, you will have something like y n. I'm just writing y n at 0. I'm just writing it like this. Just for the sake of ease, आप ऐसे नहीं लिखेंगे, आप पूरा लिखेंगे. right? So this is what you will get. So you can find out for n equal to 1, for n equal to 2, and for n equal to 0. Sorry, n equal to 0 and n equal to 1 के लिए values आप निकाल सकते हो इसमें से. What is the first order derivative of y at 0? And what is the value of this function at y equal to 0? It is 2
At
by
y
5.
equals to 0, it is 2 by 5.
Right. And the first order derivative of y at 0 is, I'm giving the value, I'm giving you the value, it is 19 by 25. So आपको ये values अगर directly मिल गई तो आप इसकी higher order derivatives निकाल सकते हैं.
Yes, ma'am.
हाँ या ना?
मैम एक बार दोबारा से
Yes,
repeat-
ma'am. Yes, ma'am.
What I am saying is कि अगर आपने एक बार ये equation निकाल ली, now what you have is this statement, this equation you have calculated. ठीक है? You can also calculate y at 0, and you can also calculate y dash at 0. ये आप निकाल सकते हैं. ये आपका आ गया 2 by 5 and this is your 19 by 25, right? So अगर आपको y2 निकालना हो तो वो कैसे निकालेंगे? यहाँ पर आप वैल्यू उसको सब्स्टिट्यूट कर देंगे. n क्या है? 2. तो ये क्या हो जाएगा? 2 by 5 into 2 into 19 by 25 minus 2 into 1 divided by 5 into n minus 2 क्या हो गया? 2 by 5. इस तरह से आप वैल्यूज को कैलकुलेट कर सकते हैं. एंड यू कैन कैलकुलेट दी हायर ऑर्डर डेरिवेटिव्स ऑफ दिस फंक्शन y, right?
Yes, ma'am.
So so this is how you can calculate the higher order derivatives of a function. So this Leibniz rule is very important and is useful in calculating the higher order derivatives. I am sharing my screen again.
Ma'am, it was already on share.
I said I'm sharing my screen again so that I can show you something that I want to show you. Okay.
Oh, all right.
So you can take the screenshot of this screen so that you have in handy some of the nth order, so that you can have the higher order derivatives of frequently used functions. For example, this is the nth order derivative of ax plus b raised to power m. So if you want to calculate the higher order derivative or nth order derivative of function ax plus b raised to power m, it is equal to m factorial divided by m minus n factorial into a raised to power n into ax plus b raised to power m minus n, given the condition that n is less than equal to m. Okay. So these are some of the frequently used functions for which you can just take a click and keep it handy so that you can use them whenever you have to solve a question.
Yes, ma'am. Ma'am, can you scroll
And
down a bit?
yeah, I have scrolled it. You can take, there are 8 derivatives. It will be nice if you write them down, but I know you are not going to write them down. So that is why I straight away said that you can take the screenshot. It will be nice if you can write them down, because when we write, we learn it. We are able to remember more.
Ma'am, can you show the first 3 again?
I guess now you can take a screenshot. You have most of them. ठीक है? Next, I will start next time.
Excuse me, ma'am.
हाँ
कुछ
जी.
चैप्टर 1 मतलब इन्फिनिट सीरीज से रिलेटेड पूछना था, उसके जो डाउट क्वेश्चंस होंगे उसके लिए एक डाउट सेशन हो सकता है क्या?
Yes, we can have that. Yes, we can have that. For that, what you can do is, कि आप अपने जितने भी डाउट्स हैं पूरी क्लास आप अपने इकट्ठे कर सकते हैं. आई एम नॉट गोइंग टू टेक जैसे एक क्लास में एक स्टूडेंट के लिए लिए, दूसरी क्लास में दूसरे स्टूडेंट के लिए. नो, वी आर नॉट गोइंग टू डू लाइक दैट. You can first compile the doubts of the entire class, send the doubts to me, and then we can fix up a class so that it is the most fruitful class in
Okay,
terms of
ma'am.
doubt clearance. Reason
Okay,
is
ma'am.
suppose you ask me some question and I'm not able to solve that question on the spot, so that I have solved all the questions and then we come in the class, then it is fine.
Should we send it through the CR?
Yes, please. You send it through the CR.
Okay, ma'am. Thank you.
Okay, ma'am. Thank you.
Yeah. One more thing I want to discuss with you, not regarding the subject. Let's close the books and copies, and I want to discuss with you something. So in DTU, I don't know if you are told about that or not. In DTU, there is a concept, especially during the online classes. Class coordinators have been assigned. Class coordinator faculty is a class coordinator, and I have been assigned as a class coordinator of your class. Class coordinator, you can assume something like a class teacher, the concept that you have in your schools, right?
Yes, ma'am.
Yes,
So,
ma'am.
Yes,
do you
ma'am.
have information regarding that I am your class coordinator?
No,
No,
ma'am.
ma'am.
No, ma'am.
No, ma'am.
No, ma'am.
Okay. So, out of all the teachers teaching you, one teacher is randomly selected to be your class coordinator. Okay. So, I have been selected to be as a class coordinator of A12. So, it is about if you have any problem means any problem related to your family, how I'm not that which I cannot solve, but pertaining to DTU, if you have any problem, you can contact me. You can contact me personally. Okay? You need not come through the CR always for this, but maybe if you have problem in any other class or in any other subject, I cannot teach you that subject, but I can escalate your problem to higher authorities. Okay?
Yes,
मतलब
ma'am.
we can find a
Yes, ma'am.
Yes,
solution.
ma'am.
मतलब we can try finding a
Yes,
solution in
ma'am.
the class itself, or we can escalate the problem in the higher authority. ठीक है? So if you have any problem related to any subject, any other administrative matter in DTU, or any other problem that you are facing, you can contact me. ठीक है?
Ma'am, ma'am,
I listen. Just let me complete. Why I mentioned your personal problem also. If that is being hurdle at any point in doing the classes, then you can contact me. अगर कोई पर्सनल प्रॉब्लम भी है जिसकी वजह से आप क्लासेस नहीं कर पा रहे हैं या कुछ प्रॉब्लम हो रही है, यू कैन कॉन्टैक्ट मी. ठीक है? आई विल प्रोवाइड यू माय कॉन्टैक्ट नंबर फॉर दैट मैटर. आई एम राइटिंग इट माय इन द चैट. Fine. You can use this number and you can contact me for any problem related to DTU, or this is my WhatsApp number as well, and my email ID is sorry, it is DTU. It is DTU, trashagupta@dtu.ac.in. So for any problem, you can contact me. I will be there. All that I can say. In case I'm
ma'am,
not able to
excuse
solve
me,
the
ma'am.
problem, Anji Saurabh.
मैम फीस अपडेट नहीं हो रही है मैम बच्चों की हमारी क्लास में। मैम कई बच्चों का फीस अपडेट ही नहीं हो रहा है, पेमेंट के 2 दिन हो गए हैं मैम। उसके लिए बहुत केओस क्रिएट हो रहा है क्लास में मैम।
Okay. I'll try to look for it. I'll try to look for it. And related to your problem, if you are hesitating in contacting me in the class, first of all, we are not going to take up any problem, any personal problem in the class. Okay, we can have it. We can have a discussion after the class, or you can suggest me that once in a week or twice in a week we can keep some half hour or 1 hour to discuss any issue raised in the class. Matlab, if you have any issue being raised in the class, we can keep some time slot. Like Saturday ko, we can have half an hour, 6 to 6:30, or on Thursday, sorry, or on Wednesday 5 to 5:30. सॉरी, आपको फ्री होता है ना, 12 से 1 क्लास होती है, और 1 to 1:30. Wednesday को 1 to 1:30 we can have a discussion if you have any doubt. So you can just tell me. ठीक है, but not in the class. Let's keep it apart from the class.
Yes, ma'am.
ठीक है, तो अगर अभी भी किसी को one point is noted that you have issues regarding the fees not being updated in the portal. I'll try to find it out and confirm you through the CR by next week. ठीक है,
ओके मैम,
Yes, ma'am.
थैंक यू मैम।
अभी के लिए इतना ही इशू है या और कोई भी इश्यूज हैं आपके?
नो मैम।
And let's try not call it a issue. Let's try to call it a challenge, and we'll face this challenge and solve this challenge for sure. ठीक है?
Yes, ma'am.
Let's be positive in life. We all are facing this pandemic period, and ठीक है, अब कुछ टाइम है तो है, करना तो है, तो we will manage with it, right?
Yes, ma'am.
Yes, ma'am.
Okay. So let's be positive, and you can share your positive thoughts. I may share my positive thoughts. How many of you? Let's have some personal interaction. How many of you are from Delhi or outside
I
Delhi?
am.
I'm
I
from Delhi.
also. I am from Delhi.
From Delhi.
I'm
Most
from
of
Delhi
you,
too.
most of
Mostly.
you.
I'm from Rohini.
I'm from
Okay,
Delhi.
from Rohini.
I'm also from Rohini.
From
Okay,
Rohini.
Ma'am,
I
I'm
also
from
from
Delhi,
Rohini.
okay. So
outside Delhi.
most of you are from Delhi, and okay. How many of you are not from Delhi? I'm not biasing on the basis of location. So I just want to find out those who are outside Delhi. I hope they are not facing any problem regarding net challenges.
No, ma'am.
Okay,
No,
you
ma'am.
have good speed.
No, ma'am.
मतलब net access easily हो सकता है आपको. My
Yes, ma'am.
concern was कि you are not facing any challenges related to your internet, because
No, ma'am.
दिल्ली से बाहर शायद हो सकता है थोड़ा सा कम हो नेटवर्क स्पीड या जो भी है.
मैम
मैम
मेरा
मुझे थोड़ी
थोड़ा
नेटवर्क।
कॉम्प्लिकेटेड है मैम। मेरा क्या है, पापा डिफेंस में है, तो एक्चुअली आई एम बॉर्न इन दिल्ली, लेकिन डिफेंस में फिर इधर उधर जाते हैं। तो 10th मेरी दिल्ली से है, 12th मेरी या महाराष्ट्र से है। तो मेरा वैसा
Okay.
है, वैसा सीन है मेरा।
So right now you are in Maharashtra. Can we all keep the videos on? It will be nice so that we can have some personal interaction time. My daughter is sitting with me. So here is my
Hey.
daughter sitting with me.
Hello.
So
Hello, ma'am.
so we can have some personal relation or in this during this hour. That's okay. बाल बनाने की जरूरत नहीं है. ठीक है. Okay. Chalo, that's good that you are not facing issues related to internet. And are you able to access books in library?
Yes, ma'am. Our seniors shared links for books.
Okay, that's good. That's good. So are you in touch now with your seniors?
No, ma'am.
Yes, ma'am.
Not
Right?
Yes, ma'am.
No, ma'am.
लिंक एरिया था.
No, ma'am.
Yes, ma'am.
Okay. Okay. So most of the problems are solved by your seniors. थोड़ी बहुत प्रॉब्लम्स होती है, एडमिनिस्ट्रेटिव चैलेंजेस होते हैं जो टीचर्स कर देते हैं, बाकी जो प्रॉब्लम्स हैं वो तो सीनियर्स ही सॉल्व कर देते हैं, है ना. आधी से ज्यादा प्रॉब्लम्स तो हमारे सीनियर्स ही सॉल्व कर देते हैं. One thing I would like to say about DTU is please be punctual. Don't miss classes. It's taken very seriously, especially for first year. And so don't, I mean, don't try to play with teachers. Teachers are really smart here. So you don't try to play with teachers. And please be serious from first year onward. अगर CGPA है ना, तो लास्ट तक वो हाथ में नहीं आता है वो, ठीक है. तो be serious for your studies. You are in college now. Don't take it lightly. Take it seriously. All that I can say. ठीक है. So let's sign out now. And if you have any problem, you can share. ठीक है.
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
चलो.
Yes, ma'am.
चलो.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Okay.
Thank you, ma'am.
One में you can just list down the problem. Yeah. Okay. I'm leaving the room.
Thank you, ma'am.
Okay.